Okay, so we're going to go ahead and wrap our lesson up on graphing rational functions. We have one more type of example that we're going to look at. We're going to look at two examples of this type, but up to this point, we have been given a rational function and asked to sketch the graph. And in this last set of two examples, we're going to be given the graph of a rational function, and then we're going to use it to come up with the rational function which has that graph. So for this first set of examples, or the first example, directions say to find the rational function that has the given graph. And we have the graph below right there. Okay, now when it comes to us constructing the rational function that has this graph, there's a specific order that I want you to construct this rational function in. Okay, so the steps that we're going to use to construct the rational function are over here to the right. So step number one is we're going to identify the x-intercepts. Step two, we're going to identify the vertical asymptotes. Step three is to identify the horizontal asymptote. Step four is for us to check the y-intercept. Okay, so when we look at this function, first off, the x-intercept. We know x-intercepts are the zeros of the numerator in lowest terms, and our graph has an x-intercept at x is equal to 0. Okay, so that means that we need to have a factor of x in our numerator, or like x minus 0 in our numerator. And because our graph touches the x-axis at that point, we know that the multiplicity of that 0 in the numerator has to be even. It has to be 2. Okay, next, we are going to check the vertical asymptote. So when we look at the graph of our function, that graph has two vertical asymptotes. It has one at x is equal to -2. So that means that x plus 2 has to be a 0 of our denominator, because again, vertical asymptotes, they are the zeros of our denominator in lowest terms. And when we look at the behavior of our graph as we approach that vertical asymptote, my graph is going in opposite directions as we approach that vertical asymptote. So that tells me that the multiplicity of my 0 on bottom has to be odd, which in this case it is. Okay, and our other vertical asymptote happens at x is equal to 2, which means that x minus 2 has to be a factor of my denominator. And because my graph goes in opposite directions at that vertical asymptote, we know the multiplicity of that 0 on bottom has to be odd as well. Okay, so you can write your rational function as like x squared over x plus 2 times x minus 2, or if you want to write it as x squared over x squared minus 4, that's okay as well. Let's go ahead and check steps 3 and 4. So horizontal asymptote, when we look at our graph, we see that that function has a horizontal asymptote at y is equal to 1. Well, what does that mean? Well, that means that the degree of the numerator and denominator have to be the same, which they are. The degree of the numerator is 2, the degree of the denominator is 2, and the ratio of the leading coefficients has to be 1. Well, the leading coefficient on top is 1, leading coefficient on bottom is 1, so that has a ratio of leading coefficients y is equal to 1, which is our horizontal asymptote. And then lastly, the y-intercept. Like if we want to determine the y-intercept, we plug 0 in for x and solve for y, and that gives us 0 divided by -4. And that graph, sure enough, has a y-intercept at y is equal to 0. Just to take this like one step further, just to confirm that this graph is correct, when we look at that graph, what type of symmetry does that graph have? And hopefully you can tell that that graph has y-axis symmetry. which means that the function is an even function. And if we try testing to see if this function is even, when I take r of negative x, that would give me x squared over x squared minus 4, the original function that we started with, which is equal to r of x, which in fact makes that function even. So that gives us like one additional check on top of what we already did to determine the graph of that function. Okay, so I want you guys to sketch this next graph for number 2 and go ahead and work out the equation of the function that gives you that graph. So go ahead and pause the video to do that, and then we'll go ahead and restart it whenever you guys have completed this for you to be able to check your answer. Okay, so let's check and see how we did with this one here. So again, if we run through our steps in order, step 1 is to determine the x-intercepts. Okay, so if we do like the x-intercepts from left to right, our first x-intercept occurs over here at x is equal to -2. So that means that x plus 2 has to be a factor in our numerator. And because the graph touches the x-axis at that point, the multiplicity of that 0 has to be even. So we'll go ahead and make that exponent 2 for the time being. Our second x-intercept occurs over here at x is equal to 5. So that means that x minus 5 has to be a factor in our numerator. And because our graph crosses the x-axis at that point, the multiplicity of that 0 is going to be 1, or it's going to be odd. We'll go ahead and leave it as 1 for the time being. Okay, step 2 is to determine our vertical asymptotes. So our first vertical asymptote, if we're going from left to right, occurs over at x is equal to -5. So that means that x plus 5 has to be a factor in our denominator. And when we look at the behavior of our graph at that vertical asymptote, our graph goes in opposite directions. So that means the multiplicity of that 0 on bottom has to be odd. We'll leave it as 1 for the time being. Okay, and our second vertical asymptote occurs over at x is equal to 2. And when we compare the behavior of our graph at that vertical asymptote, we know x minus 2 has to be a factor in our denominator. And because the graph goes in the same direction at that vertical asymptote, the multiplicity of that 0 on bottom needs to be even. So we'll go ahead and make that 2 for the time being. Okay, third thing we want to do is determine what the horizontal asymptote is. So the horizontal asymptote is at y is equal to 2, which again tells me two things. Number 1, that the degree on top and on bottom have to be the same. And when we look at the degree in the numerator, the degree on the numerator is going to be 3. The degree in the denominator is going to be 3 as well. Okay, and it also means that the ratio of the leading coefficients needs to be 2. And right now, the leading coefficient in the numerator would be x cubed, which would be 1. The leading term in the denominator would be x cubed as well, which would make it have a leading coefficient of 1. That ratio is not 2, it's 1. The only way I can make that ratio 2 is by putting a factor of 2 out front, which now makes the ratio of the leading coefficients 2. Okay, last thing for us to check to see if our function is correct is to check the y-intercept. So when we look at the graph of our function, it has a y-intercept here at -2. So let's plug 0 in for x and see if we get -2 for y. Okay, so when I plug 0 in for x, we're going to get 2 times 2 squared times -5, and then on bottom we would get 5 times -2 squared. Okay, so when I multiply the top 2 squared is 4, times 2 is 8, times negative 5 is negative 40. And on bottom, we would get 5 times 4, which is 20. So that is, in fact, negative 2. So that y-intercept checks out, which means this function right here is the correct function for the graph that is provided. Okay, and I think like of the two problems, I think this second question is like more representative of the difficulty that you guys would see on a test. Okay, so that's going to wrap up our lesson on graphing rational functions. Hope you guys have a great day.